Welcome back to my channel. In this video we will see the characteristics of ideal operational amplifier. Before that we will see the equivalent circuit of an amplifier. So this is the equivalent circuit of an amplifier. Here this Ri is the input resistance of the amplifier and this R0 is the output resistance of the amplifier. These two terminals are inverting and non-inverting terminal of the operational amplifier, and this source is called Thevenin equivalent voltage source, and R0 is the Thevenin equivalent resistance looking back into the output terminal. So this operational amplifier amplifies the difference between these two input signal, and the output is equal to AOL PD, and AOL is the open loop gain of the operational amplifier. Next we will see the characteristics of ideal operational amplifier. This symbol shows the ideal operational amplifier. The first characteristic of ideal operational amplifier, it has infinite open loop voltage gain, that is AOL is equal to infinity. So AOL voltage gain, which is equal to output voltage divided by input voltage. In operational amplifier, this input voltage is the difference between the inputs which is applied at the inverting and non-inverting terminal. So V0 divided by V1 minus V2, that is equal to V0 by Vd. So in ideal operational amplifier, this open loop gain is infinity. To get infinity for any finite output voltage, this Vd value is essentially 0. Okay, to get this infinity, definitely the Vd value is 0 because V0 is a finite value. So only I have written Vd is equal to 0. So in ideal operational amplifier, the difference between the inputs are 0, which is applied to the operational amplifier. So that is Vd is equal to 0 for ideal operational amplifier. Next one, it has infinite input impedance, that is Ra value is infinity. So if the input impedance of the operational amplifier is infinity, means it draws no current from the source, that is no current entering into the operational amplifier. So only I put I1 is equal to 0 and I2 is equal to 0. It has infinite input impedance, so it draws no current from the source. The next one is, it has 0 output impedance, that is R0 value is equal to 0. So if you come into this equivalent circuit, here the output resistance is R0. This R0 value is 0 for ideal operational amplifier. If it is 0, it acts like a short circuit, so your V0 becomes AOL PD. So your output does not depends upon the load. It depends only on Vd value, that is the difference between that input voltage. So next one is 0 offset voltage, that is VIOS is equal to 0. Here you have to know what is offset voltage. Offset voltage means if you are giving 0 input voltage, that is V1 0 and V2 0, then definitely the output V0 is equal to 0. But in some cases, you may get some output voltage even though the input voltage is 0. That output voltage is called offset output voltage. But in ideal operational amplifier, that offset voltage is 0. The meaning is, if your input voltage is 0, the operational amplifier, that is your ideal operational amplifier, output is also 0. So here for input voltage 0, your V0 is also 0. Next is CMRR, that is common mode rejection ratio. Here for ideal operational amplifier, CMRR value is infinity. CMRR, which is equal to differential gain divided by common mode gain, which is normally expressed in decibel. Here CMRR value is infinity, so the meaning is AC value is 0. Next one is slew rate. It has infinite slew rate. The slew rate means how fast, it defines how fast your device react to the input changes. Ideal operational amplifier simultaneously changes its output with input. If there is any changes in the input, immediately it will respond to that input and correspondingly it will change the output. So slew rate is equal to infinity. And the last point, it is not affected by the temperature. Temperature will not affect the performance of the ideal operational amplifier. That's all about the characteristics of ideal operational amplifier. Next, let us compare the characteristics of ideal operational amplifier with the practical. First one, voltage gain. In ideal operational amplifier, voltage gain is infinity, but in practical amplifier, it is in the range of 10 power 5 to 10 power 6 or 7. And next one is input resistance, or that is input impedance. In ideal operational amplifier, it is infinity, and in practical operational amplifier, it is in the range of mega ohms. And output resistance is 0 in ideal operational amplifier, and in practical operational amplifier it is in the range of few hundred ohms. And offset voltage, here it is 0, but there is some offset voltage in the practical operational amplifier. Here it is not equal to 0. Even though if the input voltage is 0, it has some output voltage. And next one is bandwidth. Here the bandwidth is infinity, that is an ideal operational amplifier, but in practical operational amplifier the bandwidth value is very small, but we can increase the bandwidth by providing negative feedback. And next one, slew rate. Slew rate is not equal to infinity, and if you are choosing higher slew rate, then the performance of the operational amplifier is better. That's all about the characteristics of ideal operational amplifier. In my next video, we will see the feedback amplifier.